In the previous part of this, we set up and solved the airflow. Next, what we're going to do is we're going to add particle tracing. So we're going to add a second physics, set the particle properties, and then set up the particle forces and the drag on the particles. Just like before, we'll set up inlets and outlets and then see what you do at the walls. And then we'll add a transient study. We're going to do this as a two-step solution. Okay, so let's go ahead and do that. I'll right-click on Model and add another physics. Let's see, recently used, that's, let's see, what else? Single phase. Let's go down, particle tracing for fluid flow, right-click and add it. Okay, and then what I'd also like to do, let me scoot this over so I can see this next one. I'd add another study. In this case, it's transient. Need to have the particles going in time, and we'll be done. So let's hit finish, and we're all set up to go. All right, now let's talk about adding particles. Okay, so when you're doing particles, we want to first set up what the particle properties are. If you look at what we defaulted to, we've got walls that are frozen. I'll talk about what the heck that means in a minute. And we've got these particle properties. Now we've got a number of ways to specify particle properties. Let's do it by density and diameter. So we'll leave it at 2200. And then let's make these 10 micron particles. So now I've got 10e minus 6 that are the particle size. Now, I got particles defined, but I'm not releasing them anywhere. I have no forces on them. So let me fix that. I'm going to right-click on the physics, in this case, particle tracing. Particle tracing. And then we can put all types of forces on here. We can define our own. We can do a drag, gravity, electrophoretic. I mean, there's all types of stuff we can do. We can actually have the particle influence the fluid if we wanted to. We're not going to do any of that. We're going to just put on a fluid dynamic drag. So I'll pick drag force. And says, oh, where is this drag force? Well, it's everywhere. So I'll set all domains. And now I'm going to go down and I'm going to choose the velocity field. So I'll do velocity field right here. Okay, now I've got particles that have drag, but I haven't released any. So let's go fix that. Right click. I'll add a inlet right here. And it says, oh, where is this inlet? Well, it's right here at the hallway. It says, okay, when do you want to release the particles? Well, at time 0, that's fine. I could do, whenever I want. I'm going to do it mesh-based, based on density, just evenly distributed, and let's just do 1,000 particles. You can do as many as you want. And then we want to link it on the surface right here to the velocity field. So I'm going to change that to velocity field. That way the particles are already moving with the inlet flow, which would be what they are doing in this particular case. Okay, now I got particles going in. I better let particles go out. So I'm going to right click again. I'm going to choose an outlet. And in this case, it's at the end of the hall right there. And then at the window, let's see, that one, right click. And then this one, that window, come on, window, right there. And I'll right click. So now I've got these particles that are going here. Now, at this point, what the heck is this freeze and disappear? Well, disappear is exactly what you expect. This is what you want to show if you're showing this to your manager or you're showing this to your professor. The particles go out, they go out the window, they're gone. Okay? The trouble is they're gone and we can't count them. So instead, what we have is this thing called freeze. So they go to this open window, this open door, and then what we do is we freeze them right there. And with them frozen, we now know their momentum, we know how many were there, we can do all types of statistics on them. So in this case, since I want to get transmission statistics, I want to freeze them. So I'm going to leave them on freeze. Now, same thing is going on these walls. So let me pick the default walls. Now, if you notice, all of the things that I just put in where the outlets are and the inlets, those are overridden already. But if you notice, the wall condition by default is freeze. Now, in this case, that's probably not a good condition. What I want it to do is if a particle hits the wall, I don't want it to just stick there. And the choices you've got are bounce. That's what we're going to want. Bounce is it just elastically hits the wall, bounces back in. And if I'm worried about at least, gee, someone set off a dirty bomb and I want to know what's going into my office, I want the worst case. I want them to bounce. Freeze is what I just talked about. They actually freeze there, but all of its momentum is retained. Stick almost is like freeze, only the momentum goes down to 0. And disappear, well, we certainly don't want that. They don't go through the walls. All right, so we're going to choose bounce, and we're all set. All right, now believe it or not, we're set to go. We've got 2 studies. The first study was the one that got set up when we did the flow problem. And if you look at here we've got the stationary problem. It lists all the physics. Okay? Now the other option is right here, study 2. Now in study 2, this is when we had the particle. We said, gee, why don't we have a transient? So we added a transient step. This is great. So I'm going to highlight this. And again, I'm not going to calculate flow. I already have that. So I'm going to deselect laminar flow. And if you notice, here I've got particle tracing for fluid flow. Now, since it's a separate study, it's got to know where the heck to get this laminar flow. So what I'm going to do is I'm going to open up values of dependent variables. And I'm going to say, for those not solved for, what do you want to do? Well, I want to use a solution. Says, oh, which solution? Well, let's use the solution we got out of the stationary problem. Now we're all set. We're ready to go. The only thing I need to tell it is how long to simulate this thing in time-dependent mode. So I'm going to come back up to the top of time-dependent. And then I should have opened this up. Oh, well, that's all right. I'm going to open this up a little bit. I'll pick this button for the range. And let's do 360 seconds, 360. And let's do it in steps of 2 seconds. So we'll get reports every 2 seconds. And we're all set to go. So I'm going to hit replace on that. And I'm ready to go. So right-click on Study 2 and hit Compute. Looks good. Let me come back down here. And now what I've got is my particles. And again, let me just make sure. Yep, 1 minute, 50 seconds. So it took me, in this case, it took me almost 2 minutes to solve this guy. All right. So let me do a couple of things. Let me close all this stuff up a little bit easier to see. I'll go down to my results. I'll go to my particle trajectories. Let's open this up and let's clean this up a little bit. First of all, on the particle trajectories themselves, let's change the line style to a line. That gives us this. And we get our nice stripes right here. And then one more thing, I actually don't know I don't need to know the velocity of these things. So on the color expression, I'll turn off the color legend and then plot that. And now I've got a nice plot right here. Now, it is absolutely no fun to make a time-dependent plot without making a movie. So let's go ahead and do that. So I'm going to choose player. And then it's going to build a frame-by-frame movie of what we have just done. There go the particles, moving right along. 134, 160. Looks like if you want to be in this room and it's really something awful, stand here. Once it is done building the movie, of course, then it's there for good. I can rerun it. I can, export this sort of thing and then use it inside a PowerPoint or anything else that I want to do.